So now we're going to be talking about Snell's law, and Snell's law is used to find the angle of refraction. So it's basically the index of refraction of a material can be used to figure out how much a ray of light will be refracted as it passes from one medium to another. And as mentioned, the greater the index of refraction, the more refraction occurs. So we can use Snell's law to help us find the angle of refraction for light traveling between any two media. So the formula for Snell's law is Ni, and this is going to be the index of refraction of first medium. So times the sine theta 1, and that's I, and that's going to be the sine of the angle of incidence. And that's going to be equal to NR sine theta R. And those are going to be the index of refraction of second medium. So second medium. And that's going to be the sine of the angle of refraction. And usually that's the usually we're always trying to find the angle of refraction, but it depends on what's given and what's what you're trying to solve for. You use this formula. So I'm gonna erase this. And we're gonna put it up here. So it's gonna be Ni sine theta equals NR sine theta. And that's going to be our formula that we're going to use for this example. So we're going to actually apply this now. So we have one problem, and it's a sample problem, and it says light travels from air into an optical fiber with an index of refraction of 1.44. It says if the angle of incidence on the end of the fiber is 22 degrees, what is the angle of refraction inside the fiber? So we know that we know that the index of refraction, the index of refraction for air is 1.0. So we're going to have we're going to call it Ni. So Ni equals 1.00. And then we know that the sine of the angle that we're going to use is going to be, for the index of refraction, is going to be sine theta I, and sine theta I is going to be sine of 22 degrees. And then it gives us the fiber, and the index of refraction for the fiber, which is going to be the NR, is equal to 1.44, and we're trying to find the angle of refraction, which is going to be sine R. So if we, let's see, we're going to condense this a bit so it can be a little bit smaller so we can use the whole board and show our work. So it's going to be Ni equals 1.05, and theta I is going to be 22 degrees, and then the NR is going to be 1.44, and now we're trying to find theta R. Now I plug this in, so we have 1.00 sine 22 degrees is equal to 1.44 sine theta. So we're going to do sine theta is equal to 1.00 divided by 1.44 multiplied by the sine of 22, and that gives us 0.260 for the sine of theta. So we're going to do the theta r, we're going to call it theta r so that we know it's the angle of refraction, is equal to the sine inverse of 0.260, and that gives us a refraction angle of 15 degrees. So now we know that the angle of refraction for medium of air, angle of air, which is 22, going through fiber, an optical fiber with the index refraction of 1.44, and it gives us an angle of refraction of 15 degrees. And that is how we apply Snell's law to finding the angle of refraction.